Hey everyone, this is a simple distillation setup, and I'm going to go through a quick video to show you how to set this up, as well as show you some tips to get the best distillation results. So first, because we're going to be distilling 50 milliliters of our mixture today, I'm going to use the 100 milliliter round bottom flask. Remember, whenever you choose your boiling flask or round bottom flask, you want to choose a volume of flask so that the mixture that you're distilling fills the volume about halfway, right? So since we're distilling 50 milliliters, I'm going to go ahead and choose a 100 milliliter flask. Now, what you're going to do is you're going to get a utility clamp. A utility clamp is a clamp that has a pretty large size clamp at the end, right, that you attach to a ring stand. If you grab a smaller one, if it looks very tiny, that's a thermometer clamp, so we don't want that. I don't want to boil this too fast, right? That if you boil it too fast, you basically ruin your distillation, right? You want a slow, even boil. So if I'm too close to the Bunsen burner, I'm not going to be able to control how much heat the mixture is receiving. So I want to set it a distance of about 6 inches so that I have the ability to turn up the heat if need be, but also turn it down appropriately. Now, once you have the boiling flask in there, then you're going to take your condenser. In this one, because we only need one condenser, we're going to choose to use the fat condenser, right? Remember, if you ever just use one, use the fat condenser. Only when you use, you'll use the skinny condenser when you're going to be using both condensers in a fractional distillation. So I'm going to take a utility clamp and clamp it to the meat of the condenser, not the nose down here, not the top right there. Clamp it right in the middle. These condensers can be very expensive, and so we want to make sure that they're on here securely so that these two pieces of the distillation apparatus can exist completely by themselves, right, if it were to come apart midway for some reason. Right? Now, the connection between the boiling flask and the condenser is going to be our T-piece or our three-way adapter. Right? Now, whenever you're connecting glassware for a distillation apparatus, there are edges that are ground glass. And what you're going to do is you're going to take a little bit of vacuum grease and just put a dollop on your finger, not too much, and just go around the outside. And what this will do is we'll make an airtight seal between the glass components of the distillation apparatus. You would like to use these blue distillation clips, right? Not here, never right over top of the flame, because if you put it on top of the flame, what's going to happen is they're just going to melt. And then I'm going to get my thermometer adapter. I'm going to put in a low temperature thermometer. What I mean by low temperature is one that only goes up to about 120 degrees Celsius. We have some high temp thermometers that go up around 240, 220, 240, depending on which one you're using. We don't need that in this setup because our mixture is going to boil under 100 degrees Celsius. So as the mixture boils, what's going to happen is the vapor is going to come up into the three-way adapter and it's going to come down through the condenser. But right now we don't have any water in our condenser, so the vapor wouldn't be condensed. It would just exit the condenser as a vapor. So we need some cool water in there to cause that vapor to condense back into a liquid. We have hoses that are attached to, we have one hose right here that is attached to the faucet, and I'm going to put that hose right here at the lower end of the condenser. Cold water in down here. But if I were to turn this on right now, I'd just shoot water straight out of there. So what we need to do is we need to put another hose that will transfer the water right back into the sink. So now when I turn this on, it fills up the condenser and comes down right here into the sink. Now at this point, right, what I would have to do is I have my distillation set up all ready to go. I can disconnect it for a moment and add in my liquid to be distilled, right, my mixture. But what you have to do is you need to give that liquid somewhere to boil for the boiling to start, called a nucleation site. And so it's important that you add some glass beads down into the boiling flask. Just a few, like 3. You don't need many. So you're going to add a few glass beads in there. A few glass beads in there. And what that will do is that'll provide surface area for the phase change from liquid to gas to occur. And so that you don't have this random boiling happening all over the boiling flask and then potentially overflowing into our distillation apparatus.
So here we have a running distillation setup. Take notice that the volume in the boiling flask is a little bit less than halfway because we've been going for a little bit. We can see condensation in the condenser where the water is cooling the vapor back into a liquid. And occasionally there's some drips coming off of the nose piece into our collection vessel, which is a graduated cylinder. You'll know your distillation is happening at an appropriate speed if you see that the drips are coming about once every 3 seconds. That should come to approximately 20 drips per minute. To get this nice rate of about 20 drips per minute, you need to make sure you don't heat your boiling flask too vigorously. You want to have a good boil, but you don't want it to be boiling so much that you're worried about it over boiling into the condenser. The glass boiling beads really help make it a nice even boil. I want you to also notice the location of the blue thermometer bulb right now. It's not so far down as to get an artificially high temperature or too high up, so that it gets an artificially low temperature. It's capturing the appropriate temperature of the vapor that's entering the condenser. Throughout the distillation, it's also important that you keep a regular eye on the temperature because that's going to give you an idea of what substance is currently condensing in your collection vessel. One common mistake is failing to hook up your water hoses correctly. So we want to make sure cold water enters at the bottom of the condenser where it's the coldest, and then it comes out the top where it's already been used to cool the vapor into a liquid. As this distillation has occurred, I've been collecting the distillate in 10 milliliter samples, starting with the first bit of distillate that started to distill around 65 degrees Celsius, all the way until close to the end when we were distilling at near 100 degrees Celsius. On Saturday, you'll receive this data, and I'll expect you to present it in a way where you discuss whether or not the densities match what you would assume the identities of each fraction would be.